Knowing the required equipment, network and desktop operating systems and applications needed in a network is a must. Here's a network that you can apply from a small to a medium-sized company. It has all the necessary equipment required in our network. 2 layer 2 switches, switch 1, switch 2. A layer 3 switch, NXOS. A domain controller where you can create and authenticate users. DNS server which translates hard to remember IP addresses into names. DHCP server for workstations to automatically configure their IP addresses. Default gateway and DNS. A web server that can be accessed from the inside as well as from the outside. And a firewall, CiscoASav, to secure the network. Here's the step-by-step process on how I configure the network. Starting with layer 2 switches, I created 4 VLANs, VLAN 10, 20, 30, and 40, Ether channel between the layer 2 switches, and a trunk that connects to the layer 3 switch NXOS. At the NXOS, I configured the sub-interfaces for each VLAN to allow all nodes to communicate. Note that routes of directly connected networks are automatically added to the NXOS routing table. Once the switches were operating properly, I added an ASAv firewall, configured inside and outside interfaces, routes, ICMP, outside DNS servers, NAT, and HTTP server for ASDN manage the firewall. I also configured the NXOS interface, added a default route to the firewall, and ensured all hosts of different VLANs are communicating properly, able to ping, and have access to the internet. And then I added a web server and configured the DMZ interface, NAT to translate external to internal IP address, and an access list since we are allowing users from a lower to a higher security level access the web server. Once everything were working smoothly, it is more convenient to use names instead of IP addresses. I added a Windows domain controller, configure it with DNS and DHCP server to automate and speed up the allocation of IP addresses, DNS, and default gateways to all VLAN nodes. Regarding to our web server, I created an A record on my outside DNS server of the external IP address 192.168.1.100 for public users to access the web server by its fully qualified name. Likewise, an A record on my inside DNS server of the internal IP address 192.168.3.100 for inside users to access the web server by its fully qualified name. In reality, this web server with a public IP address should be registered in your ISP for public access. Now, let's start testing for DHCP and DNS functionality, inter-VLAN connectivity between workstations, access to internet and internal web server. Let's start with guest 1. Verify DHCP assigned IP address. It should be between 192.168.5.50 to 100. Verify DNS functionality by pinging web server and domain controller by name. Now we will power up all VLAN workstations. Let's test it from a workstation in VLAN 40, a DHCP client with a Firefox browser. IP address should be between 192.168.40.50 to 100. Ping the statically assigned workstation in VLAN 10, 192.168.10.2, and default gateway 192.168.10.1. Ping also the web server and domain controller by name. Using a browser, access the internal web server using fully qualified name. Also, browse on our external internet web server and google.com. From a workstation in VLAN 20, browse yahoo.com. From the outside, log into the Windows 10 workstation. Run the CiscoASdm IDM launcher to verify accessibility with the firewall from the outside, and also browse the internal web server. Ping the web server or any inside device from the outside. You should not get a reply. There are more testing done in this video, but I'm not going to go through all of them because they are redundant. Stay tuned for my next video for a more detailed configuration on this network.